So whenever you read the word solve, solve always means find out whatever the heck the variable equals, right? So if it says determine the roots algebraically, if you get the whole thing equal to 0, you're technically finding the roots. The roots, x-intercepts, zeros, they all mean the same thing, remember? Roots means x-intercepts, means zeros. And you find them whenever you have an equation equal to 0. Why? Because if you plug this into your calculator, this would be y1, this would be y2, here would be your equation, and you'd be finding out where y1 and y2 intersect. y2 happens to be the x-axis, so you're finding the x-intercepts, right? That's why you always get it equal to 0 whenever you're finding x-intercepts. So algebraically, though, what we're going to do is we're going to solve for x. So we have 2 root x minus 4 minus 3 equals 0. If we're solving for x, what are we going to do? We're going to try and get x by itself. So the 2 is attached to the square root, which it has the x minus 4 in it. So we have to move the 3 first. So we're going to add 3. So we have 2 root x minus 4 equals 3. Remember when we did rationals last year and we solved rationals? We're going to do that again this year. But when we solved rationals, you had to state the non-permissible values, the values that x could not be, and then you'd have to check them. Same thing here. There are values that x cannot be because, for example, if x was negative 1, I'd have negative 5 under the square root, which can't happen, right? It can't take the negative. If x was 3 minus 4, I'd still have negative 1, which wouldn't work. So in this case, when it's linear like this, it's easy to do. You just do x minus 4 has to be greater than or equal to 0. So x has to be greater than or equal to 4. That's your restriction. If it's a quadratic, remember you'd have to find the x-intercepts, and you have to find out where the graph is greater than 0, right? And state the domain based on that, just like we did. When it's linear, it's easy. So what we're going to do, we're going to check at the end and see if our value is greater than or equal to 4. If it is, we keep it. If it's not, we ditch it. So our next thing we're going to do is divide by 2. You can't square at this point. I guess you kind of could, but I wouldn't. So now you're going to have the square root of x minus 4 equals 3/2. Now we want to get rid of the square root, so we're going to square both sides. So we get x minus 4 equals 9 over 4. And then we add 4. So you get x equals 9 over 4 plus 16 over 4. Because you're going to have to get a common denominator. You're going to have to multiply this by 4 over 4. And then you can put them together. X equals 25 over 4. Now is 25 over 4 greater than or equal to 4? I don't know. Put it in your calculator. 25 divided by 4 is 6.25. Are we good? Does it fit? Yes. You can always check it too by always, whenever you solve, remember you can always check by plugging in and seeing if left side and right side equal, then it works. So whenever you're solving any type of equation in grade 12, if you're solving for x, you can always check it by taking it and plugging it back in here as well, right? You'll know that if it actually is less than 4, when you plug it in, it's going to error you because you can't actually find negative. But a question on the diploma could just be, what's the restrictions on this equation as well? You need to know that. Now it says graph the corresponding function and determine the x-intercept. So plug this into y1, plug that into y2. And find out where they intersect. So you're going to get 6.25 and 0. Your answer when you solve is always the x. Now, could I do this instead? So the original equation is 2 root x minus 4 minus 3 equals 0. Could I add that 3 over and go 2 root x minus 4 equals 3? And then go y1, y2. Find out where they intersect. Try it out. All I did was I moved the 3 over. Now go y1, y2, second trace 5. Enter, enter, enter. What do you get for your point? 6.25 and what? 3, because it's just calculating between where it intersects. But my answer is just the x, so it doesn't matter. So you can rearrange this all you want into y1, y2, and still it'll give you the same answer, right? So C, compare the roots of the equation to the x-intercepts of the graph of the corresponding function. Why might they be different? So compare the roots of the equation to the x-intercepts of the graph. So when you find the roots, you might get 2 roots, but your calculator only has 1. Why? So when you solve it, you might end up with 2, but your calculator only has 1. Why? One of them is extraneous. Yeah, exactly. So how can they force you to do this algebraically? Ask you for the extraneous root and give you one that doesn't work, right? They can do it. If not, you could just use your calculator. So something to think about. You try this one. So solve this and make sure to check for restrictions and check by substitution. So I want you to solve this, give me the restrictions, and then check it by substitution. So if you haven't noticed yet, it's awful if you keep this over here, because a lot of you will say, okay, it's 9 plus x minus 1. If you did that, you're not correct. You'd have to FOIL this. So you go 9 plus 6 root x minus 1 plus x minus 1 equals x. So you could do that. That option works. But it's a lot easier if you move the 3 over here. So you're going to get x minus 1, root x minus 1 equals x minus 3. And then square it. But remember, when you square the x minus 3, the answer isn't x squared plus 9. You have to FOIL it, right? So whenever you have 2 terms squared, I always say, from forever on, I always say this. Cross out that squared and rewrite it twice so that you don't forget to FOIL, right? Everyone does. It's common. So whenever I see this from grade 10 on, I always say, cross it out, write it twice. Then you get rid of that error where you don't get the middle terms. And then this one's nice because the square just cancels it. Because it's a quadratic, you have to move everything over and set it equal to 0. I always like moving, if it's just a plain old x squared, I like moving it to where the x squared is positive, because if the x squared was negative, you have to decomp, right? Or you have to take out a negative one. If we go to state our restrictions, we have, because it's linear under the square root, we can just go x minus 1 has to be greater than or equal to 0. If it's quadratic, you can't just go do that. So x has to be greater than or equal to 1. What do you have to remember? If this was a negative x and I divided by a negative 1, what happens? Your inequality sign flips. Still says equal to, but it flips. So our answer has to be greater than 1. So we checked. It looks like they're good. We're going to check them back into our answer. How else could you check? y1, y2, right? Have one side y1, over the other side y2. Find out where they cross. If there's 2 crosses, probably good, but you can still find them. If there's not 2, you're like, oh, one's out. So I'm going to check it this way. X equals 2, x equals 5. Remember, when you check, left side stays on the left side, right stays on the right. They don't cross. 3 plus 1 equals 2. 4 equals 2. Is that true? No. So even though it sometimes passes the restriction, it doesn't actually still work. Okay? And then when you plug this in, you could move this over and set it equal to 0 if you really wanted to, or you can go y1, y2, and find out where they cross. There's a catch. Sometimes they ask you on the diploma this. Pay attention. So if they go x plus, say, square root, what was it? 3 plus square root. So they ask it in this way. They can say, okay, what two equations would you use and what would you do? So you could go y1, y2, use this as y1, use this as y2, second trace 5, enter, 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 take the x value, correct? You could keep it, move this 3 over, and you still do second trace 5, enter, enter, enter. The one that they make a little bit trickier is they'll go 3 minus x plus square root x minus 1 equals 0. Because it equals 0, what can they say you're looking for? Second trace 5, enter, 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 sure, between this and this. But because it equals 0, what are you actually finding? The x-intercepts. So they'll say y1, y2, find the x-intercepts. Or just plug this into y1 and find the x-intercepts. That's another way they can ask it. Because they can ask graphing questions. They can ask graphing questions and plugging them into your calculator. Okay? So solve this one graphically, solve this one algebraically. When you're done that, do these two. And then it's going to be homework. So if we're going to solve this graphically, you can punch into your calculator. We're going to solve it, we're going to verify it algebraically. So 4 plus the square root of x plus 4 equals x minus 4. We know x has to be greater than or equal to negative 4. Move the 4 over by minusing it. So square root of x plus 4 equals x minus 8. Square it. X plus 4 equals x squared minus 16x plus 64. Minus x minus 4. X squared minus 17x plus 60. So 15 and 2. X minus 15, x minus 2. That's hilarious. That's not true. That's not true at all. What is it? 12 and 5? That's not going to get me a thinner marker. Okay. X minus 12, x minus 5. Okay. X equals 12, x equals 5. When you plug them in, which one works? Now, is it possible for both of them to work? Sure. But always check them. And then these ones, the only catch on these ones is if it says determine the roots, you have to make y equals 0. And then you solve them just like you normally would. So those ones are easy. So page 96. Page 96, 3BD, 5B, 6AD, 7AD, and 10.